Hello, and today we're looking at aquifers. So we're going to look at the features of aquifers, their porosity, permeability, and associated geological structures, abstraction from aquifers, so boreholes, water chemistry and value, and then aquifer recharge. So aquifers are something that people struggle with quite a lot. So people imagine aquifers, they get told, is water underground. That's like the really simple description of it. And what they imagine is that under their feet there is some sort of giant cavern in the rocks full of water, just waiting there, like just as a big pool of water, like an underground swimming pool or something like that. And they imagine that they can somehow get a straw down there and suck up this water for use. Okay, but actually, this is not how aquifers work. Under your feet, there is a water table. So if you dig down and down and down and down, you reach a point at which the underlying rock and soil is all waterlogged, which means it is saturated with water. And this is called the water table. Okay, and beneath this is like the natural level to which water will permeate through the soil, or percolate, sorry, until it can't go any further down, basically. And this is the basis for an aquifer. Okay, so the features of an aquifer, we have porosity. So this is a measure of the proportion of the rock's volume, that is space, that water could fill. And therefore, rocks like limestone, chalk, and sandstone are all porous. Helps you spell it right, doesn't it? Porous. And these can therefore form aquifers. So if we had a look at the structure of these, like sandstone, so if I had a black block of sandstone that I looked under a microscope, what I would see is you have these grains of sand, and because of how they sort of fit together within the rock, you have all this void space, and this means that water could fill up these gaps. And form an aquifer. So if it became saturated with water, this would be what you could see. All right. Less porous rocks are typically much, much finer grained. And you can see if you have smaller grains, then they sort of fit together more tightly. And you have less space, therefore, for water. And if you have things like igneous rocks, like granite, they do not have pores at all. They basically cannot hold very much water at all. So this one has less void space and therefore is less porous, more porous. Okay, so permeability is the measure of the ease in which water can flow through a rock. And this is due to the interconnections between spaces. So if you can imagine, it's like the ability of water to flow within a rock. So you can have like limestone is typically quite widely fractured, and this means that it's very permeable because water can flow into these fractures and then move between different parts of the rock relatively quickly and easily. So limestone is typically very permeable. You have things like clay, however, which is not a rock, you're right, it's a bit more sort of solid than that. Clay is porous, so it has pores, but they are very small. And this basically means that a block of clay is impermeable because the pores are too small to allow water to flow easily through it. So clay is impermeable due to the very small pore sizes. Okay, clay, if you have to look at a very strong microscope to see it, but it basically makes clays in the form of plates, which like layer up like this. So you don't really get any way for which water can get through it. And then we've got associated geological structures. So we need to have impermeable rock below an aquifer to prevent water escaping. So things like granite and clay are impermeable, and they prevent the water from escaping. But then you also need permeable rock to allow recharge of the aquifer, which means water being able to soak back in and fill it back up again after it's been used. So if we have a look at drawing an aquifer, what we would find is we might have a surface. So this is not going to be to scale, I like to point out. And we might have a layer of impermeable material. So let's say that this is clay. And the water that falls on this area can percolate down to the water table. And this is our saturated aquifer. And we can access it by using a borehole, and this would require a pump to extract the water. Now, what we might find is that we have like a mountainous set of hills or something like that either side of us, and these have like a band of impermeable rock passing through it. So perhaps this is granite for the sake of argument, or clay and granite, or some other geology. So let's turn this one, that's clay in dots. So let's say this is granite. So this again is impermeable. What we have is our recharge zones on the top of the hills. And this allows water to percolate down to the water table, which might actually be higher than the surface of our valley bottom. So this is our water table. And because the water table is higher and that our aquifer is confined by the layer of clay above it, if I put in a borehole down to this confined aquifer, so this one is my confined aquifer, meaning the one above is our unconfined aquifer because it doesn't have any clay above it. This borehole here, water will come up under its own pressure because the water table is higher than it. And this means that we call these our artesian wells. And water will naturally come up under its own pressure from these, from a confined aquifer. So this one has a recharge zone above it. This confined aquifer has a recharge zone in the hills above it. And we have our water table and our saturated, unconfined and confined aquifer.